emerging topic is on digital humanities. Whatever this is, we will learn. And we learn this from Johanna Barzen from the University of Stuttgart, please.
That looks good. Welcome to my talk on digital humanities. So thank you for the nice introduction. I'm Johanna Barzen from the University of Stuttgart, from the Institute of Architecture and Application System. And I want to stress this again, because this is an institute of computer science. So it's the part of the digital that is reflected by this institute. I'm a media scientist, so my core part is the humanity part. And digital humanities actually bringing both parts together. And I really liked when I saw the program this morning that it's under the topic, or under the section emerging topics, since digital humanity is really getting a more and more serious field at university. And in University of Stuttgart this year our first master in digital humanities starts. So what I want to do, my presentation doesn't. Here we go. What I want to do the next half an hour is introducing to you what digital humanities are, so what are they aiming for, and then giving you an introduction of what we are doing at University of Stuttgart in digital humanities with our Muse project and which method we are using. And I want to come to a rather provocative hypothesis that the concept of pattern, which is used quite frequently in computer science, can be very useful and can be used as formulas in the digital humanities. So when looking at the literature on digital humanities, of course there are many different definitions. And I brought this one with me. I like this part very much that it emphasizes that there is not one way of doing digital humanities, but that, as they say, digital humanities is a diverse and still emerging field that encompasses the practices of humanity research in and through information technology, and the exploration of how the humanities may evolve through their engagement with technology, media, and computer methods. So this combination of humanities and using techniques from the digital part is quite new. When we look at how science has developed in the natural science and the engineering, it's very different. I brought with me from the book, The Fourth Paradigm, a little bit science history. Here, based on ideas of Jim Gray found 4 paradigms on how science has been done in history. He said the first paradigm was to do experiments, so describing the phenomena of the world by doing experiments to understand how they work. Then, later on, since a few hundred years, theory got more and more central. So this is the time of the Kepler law, it's the time of the Newton laws. The generalization and creating a mathematical model of our world got very important. Now, since a few decades, this mathematical model got so complex that we needed new ways to grab these things, and this is where simulation got very important. So the computation could be seen as the third paradigm in how we do science. And the fourth paradigm is that nowadays, or at least nearly 20 years now, we've got so many data that are produced by scientific instruments like the Hubble telescope or like CERN, and we need new ways to get along with all this data. And why I brought this 4 paradigms from Jim Gray with me is that you can see very nicely that the 2 of these paradigms are closely related to computer, closely related to computer science. And this is what actually the term e-science tries to grab. So So the combination of natural science and engineering with concepts, methods of computer science is used very frequently, is in an advanced state, but when we look at the humanities, this is very different. The humanities are not really into using these new techniques, and this is what the humanities, or the humanities, the digital humanities want to change. But when we look at all the projects, there are quite a few projects running on digital humanities now already, but most of them, and this is what we at least identified as a lack of the current digital humanities, they are using the computer as some help, as support to do the science the same way they always used to. So they're using databases, archives, document systems to make it more easy, but they're not really using the way how computer scientists, for example, approach their problems, how to solve problems in a new way. So they're not using the methods or concepts which are used. And this could be very promising. So what we try to do at University of Stuttgart, in our new institute, is to use two concepts which are frequently used in computer science and applying them to a question that is existing in the humanities. And since my core competence is media science, and here especially the costume, and I really mean costumes which are worn in a film, we wanted to use first of all the concept of formal languages to concretize the term costume language, because in the humanities they've got a problem sometimes of definitions. There are a lot of 100 definitions everywhere, and you can't really grab these terms. So what we wanted to do, first of all, is use formal languages to make a very clear definition of what are we looking at, what do we want to do research on. And we chose the concepts of ontologies and pattern languages to get the content of this costume language, to derive a costume language out of films we are watching. And this is what we called our Muse method. Also, we generalized this method, as well as the formalization, to make it usable for other domains in the humanities. Media science is such a very small part. Of course, there are very different other domains in humanities, and through the generalization, we wanted to make it reusable for the other domains as well, to get new insights in existing questions, most of them existing for quite a while. So what we are doing at Muse, our project, just a very short overview. The idea was that in movies, or a costume language is something that happens when you watch a person in a film. 80% of the person that you see is a costume. And this has been picked by a costume designer on purpose to communicate a certain stereotype, to communicate character traits, to communicate moods, or a time, or a place you are. And this we wanted to get out of the movies. So what we're doing is we're watching a lot of concrete costumes we can find in the movies. For example, as you can see on the top, a lot of sheriff costumes. We are storing them in our Muse tool chain, analyzing them to get costume patterns out of it. And costume patterns are the essence of all the relevant parameter to communicate this character. So what we did, first of all, is to take a very close look at the domain. So we did build quite huge taxonomies to structure the costume relevant parameters you need to describe a costume, and they got quite huge actually. We had to look at all the parts of clothes, all the colors, the materials, and so on. Based on these taxonomies, we did build our Muse repository. This is where we do store all the data on the costumes we are watching. We are analyzing this data. We started with Ola cubes, and this works very well already, and at the moment we are working at data mining, because we got so much more data than we first thought. It just makes sense to use techniques that also allow you to really dig into this data. And we got Patternpedia, which is our repository for the patterns. So The analysis gives us pattern candidates, and if we decide that they're a pattern, we can store them in our pattern repository called Patternpedia. And Patternpedia is not only for costume patterns, but for a bunch of different patterns. It's the main independent, and we at University of Stuttgart are working in quite different fields of pattern. At the Institute we've got cloud computing patterns, data migration patterns, green IT patterns, and the costume patterns, of course. I did talk quite a lot about patterns now already, so just a short definition of what I really mean with patterns. Pattern, in our understanding, are proven solutions to recurring problems. It's based on the concept that was introduced by 1977 by Christopher Alexander, who was a real architect, so building houses in comparison to other software architects. And it's a concept that aims to capture a best or a proven solution to a problem in an abstract way. So it's not, and this is important, it's not a series of concrete instructions how to do it, it's just an abstract way what we should do to solve this problem. And of course, each pattern is not standing alone, but each pattern, the pattern language is more than one pattern, and the patterns are related with different links to each other, with different types of links. And so the patterns together with the links are a pattern language in total. And the costume language here then can be defined as a proven solution to a reoccurring design problem, meaning the best solution to dress a certain character to communicate all the effects you want to have. So what we have at the end, when we've got all our costumes in the solution repository, we've got on one side the Muse solution repository, where all the concrete costumes are stored, like the sheriffs, as I've shown already, and they are abstracted to a sheriff pattern. And this pattern, of course, is related to other patterns, like the sheriff is the opponent to the outlaw, and the outlaw and the sheriff both are in love with the saloon lady, and this is how the whole costume pattern language gets composed. And if the costume designer now browses through the pattern language and she decides she does need a sheriff, she can now go into the repository, takes a look at the sheriff pattern, and can be brought back through links to the repository and can now use these concrete solutions how others have already solved this problem in a concrete way. For us, when we started this, the first thing, of course, was very interesting to find this costume language. But while we were working on it, more and more the method got interesting for us. So what we did in the second step is we also formalized this method, because we thought it's a lot of potential for other domains, as I said already. So we did take a closer look at the method we really used. So first of all, we had to restrict ourselves to film genres, restrict ourselves to the corpus. We needed to identify the characters. We needed to describe, as I showed very briefly with the repository, the clothes, the characters, the context, and so on. We needed to identify which costumes are in there. We needed to group them to patterns, and each pattern of a costume is composed out of different parts. Like my outfit has got a shirt and a trouser, these are the base elements, and my shirt has got a sleeve and a collar and some buttons. These are the primitives, and they are all stored in the ontology so that we can run good and structured analysis on this data later on. And what we now did is we described each step in this method by formal definitions. For example, when we look at the step between the clothes, which are just stored in the repository, and the costumes. Here something happens, and we have to describe this part, of course, by a formal concept. We chose here the concept, just to give you an idea what we did, of a Boolean effect function, because the difference between a costume and cloth is that a costume is clothed with an attendant effect. So to make this a little bit clear, as I said already, if a costume designer wants to do, is applying for a job, she gets a script. She reads the script, she goes through the script and identifies, of course, first of all the characters. Then she goes to the set, talks to the director, talks to the actors, talks to the set dresser, so the costumes have got the right color and the walls are blue and the costume is blue, so she has to do quite a lot of work to select the right clothes for this person. And she does this work to, of course, achieve the effect she wants for this certain movie, for this certain character. So the clothes, together with the effect she wants to reach, is the costume. And this can be described by the effect function. Does it have an effect? Yes, or does it has no effect? So no. Also, in the next step, all the costumes that have got, so all the costumes that are identified have an effect. But we need to group now all the effects that have the same effect in one group, and this can be described by an equivalence relation. So we are building equivalence classes with all the costumes that have got the same effect. So all the costumes that represent a sheriff are together in one equivalence class. And not going into detail on all the steps, we created a whole method. We formalized this method, and of course this can be mapped to the repositories we implemented. So we've got on one side the solution part, which is the domain ontology, which is the domain language, as well as the solution language, and we've got on the other side the pattern language, which consists of all the equivalence classes of the solutions with the same effect and the relations between these equivalence classes. Why did I show this to you, or why did I wanted to present this? The main part is that this can be very useful for the digital humanities, since patterns are a way to structure knowledge, and the humanities have got, they don't really have these tools to structure knowledge. And this could be very useful because it's not too strict, but it gives a good way to grab knowledge and letting you a little bit of freedom, but also making strict boundaries. And so I wanted to show how patterns, for example, and as well as the formulation, can contribute to digital humanities. And therefore I want to take you again that how are patterns used? Normally, patterns are used, you have got a concrete problem. For example, from the computer scientist domain, or from a computer scientist, I need to scale my application. To solve this problem now, you can browse through the pattern language and you find a pattern that is advising you how to solve the problem. So for example, here I've got an elastic load balancer that will solve this problem fine. Next step is you describe this concrete problem by specifying its actual parameters. So the problem context needs to be specified. This would be, my application is more as Azure, for example. And then in the next step, you can pass the actual parameters as properties to the solution sketch to get a concrete solution. So patterns are very nicely used to get a concrete solution to a problem. When we look at how problems are solved in science and engineering, you will see it's quite similar. You've got a certain problem, so you've got an equation, for example. And what you do most of the time is you get a formula to solve this problem. Next step is, of course, to describe the problem context. So you describe the concrete problem by specifying its actual parameters. These are then passed as values to formula variables, and you get a concrete problem. A solution to the problem, of course. And therefore, as we can see, there are similar steps, and we just had, as I said, a rather provocative hypothesis that pattern languages can be used quite similar, at least by analogy, as formulas. To prove it a little bit stronger, I wanted to prove it again by induction. And there again, I will take you into science history. We are now at Tycho Brahe, a few years ago, who did very detailed capturing of how planets will move. And he wrote this data down and did actually quite detailed data capturing as we are doing it today. Some years later, so 50 years later, Johannes Kepler came, did analyze this data very carefully and formalize this data into the Kepler laws. When we look again what we are currently doing, so just to sum it up, we've got a scientific method that consists of observation, data capturing, data analysis, and formalization. When we look at what we are doing in music, we are observing all the costumes which are in a certain form. In the next step, we are capturing this data in our music repository very detailed. After that, we use this data to analyze, so we are doing an analysis on this data to find the parts which are the same, to formalize them, the content in the patterns, the method in a formal language, we formalize what we have seen in the data. So it's quite the same method. It's also observation, capturing of data, data analysis and formalization. This of course can be mapped on the method we developed. Now it's already the method generalized. It's not anymore related only to costumes. Of course, the solution language can be any domain in the humanities. But the top part, as you can see, is always domain independent. So if we talk about music, for example, it's a very different concrete solution than for costumes. Costumes, I've got my clothes, in music I've got the notes. So the solution part always needs some adjustment, while the pattern part always is exactly the same. And this is why also the solution repository always needs to be adapted to the domain, but the pattern repository can stay exactly the same. To prove that this method, as I already stated, is not only restricted to costumes, we are currently really trying to use this method in music, so to find effects in music. How does a symphony in the 19th century communicate horror or some certain moods? And they are using exactly the same method we developed for music. And I said, coming back to the hypothesis, these patterns, at least as we can show for the costumes, can be very easily used in the same way as formula are used, because here again you've got a problem. You detect the solution by using a pattern, getting linked to the concrete solution to get a concrete solution. So this could be useful for the humanities to make their knowledge reusable for other people in an easy and nice way. And this is where I actually already reached my conclusion. So what I wanted to show is that also in the humanities, paradigmatic change is possible. So by presenting the method and the implementation of deriving this costume language, I wanted to show that digital humanities are not restricted to just archives or text, images, to databases, but that also the concept of computer science can reside in new insights. So modeling, patterns, formal language, semantics, and other concepts are quite promising when using them to existing problems. And therefore, even more, not only the concepts, but also the empirical method, which science always uses, maybe has another chance to get into the humanities again. And this is why we used to spread this method and use it in different domains to say that this is possible. And so I thank you very much, and I'm happy for questions.
So we thank you, and again, the floor is open for a question.
So thank you, Johanna, for a very interesting talk. This is a fascinating concept, like the idea of pattern, across the board, with the fact that, as you say, you capture the knowledge. This is it's really seems like a powerful concept. I would just narrow down to an example from the costume space. This is what to understand. You mentioned that if you specify the context, some region around time, you can get. To me, this didn't appear to be a concept, I mean a pattern. It appeared to be just an example. So in that database, would I just have a number of examples of costumes from that period that I would call that a pattern, or would I have the characteristics of that period? And therefore, if I have that, I can produce yet another one. Just and if I say, give me 1,000 costumes that don't look alike, but they conform that pattern, that database could do that.
There are a few points where I can say something to. First of all, of course, this stereotype is only one of the ideas a pattern can grab. There are a lot of other things like, you mentioned the overall time patterns, but there are also things like character traits. When you roll up your sleeves, for example, the type of wearing, it's more active, or if you button up your shirt, it's more being closed and not being opened. It's about color concepts, very strongly. Blue persons in wearing more blue are much more nicer than someone always wearing red. It's about materials. There's so many different nuggets of advice, and you were straight into the language of patterns. So there are little islands that always capture the essence of one certain part to communicate something. And it's the sheriff is just very easy to communicate, but and this is what all the different links have to solve out a little bit, because the links have to give you an entry point, and then you can grab it together. We've got, from each movie we're watching, we get about 200 costumes. And these are only the roles that are really speaking, so we restrict it to the ones that do speak. And this makes it quite a huge pile of costumes. And of course, with each movie, the patterns do change a little bit. And this is why we wanted to make it possible to run all this analysis on top of there, because you always could adjust the things, but it's not automated yet, so we're on the way.
Okay, are there further questions?
You have these very nice analogies, right, about computer science and humanities. So in our IT pattern languages, we have something like forces. We also say quality attributes. And Frank had the example of reliability, I believe, this morning, right? So as software architects, we kind of know that designing for reliability is an important issue. Mm-hmm. Your costume designers or directors, how do they know that they have a problem? How do they?
They do have a problem, which is very realistic. They don't get paid anymore for the research at the beginning. So each costume designer can just use what she's got in her head, or he's got in her head. So it would be very useful for them to have a tool to just have the opportunity to look how others have done this already.
I'm looking for the entry into the pattern language, right? They have the first set of design problems. Problem I quoted you, right?
Yeah.
Problem, solution to a recurring problem. So how do you know where to get started with this big huge space?
Difficult question, of course. This is very closely related to the question with all the different layers of the costume language. If you want to go through a mood, or if you want to go through a genre, or if you want to go through a character traits. And this is actually what Frank will be hopefully solving in the paper he presented this morning. It was a bit about the solution path and
his question is how to find the first pattern.
Yes?
Yeah, right. So what we have done, Olaf, for our Humanities system has tags. You can apply tags to the stuff, and then you describe your problem in a set of tags, and then we present you a subset of the patterns. So basically say, maybe this is the appropriate start. This is a straightforward, simple solution that we have today.
Okay. Are there more questions? It seems not be the case, so thank you again. So we are not yet finished, don't walk away. There is a next event, next talk to be given, but it's not on this place.
Absolutely.
It is given more or less in detail on another place called Café Nier. And Frank will tell you how to go there.
Yeah.
And I only can tell you it's not necessary that you have a special costume to go there.
You can come without clothes. No, the Café Nier is you go back to the main building, you go down.
There is a person from the South Parliament that will guide us there.
Even easier. So, and then some of us will go to the director's dinner tonight. So I will be at 7:50 in the lobby, if you don't know where it is, and then you